Welcome to Summarize Science, where we break down cutting-edge research. How do you teach an AI to truly think and reason, especially for tasks where there's no single correct answer, like writing a poem or a business plan? Traditionally, AI models have been trained using methods that need an automatic verifier to check their work, which is a major limitation. But a new paper introduces a method called RARO, which stands for Relativistic Adversarial Reasoning Optimization, that learns powerful reasoning skills using only examples from human experts. The core idea behind RARO is to set up a clever game. Imagine two AIs competing, a generator and a critic. The generator's job is to study expert examples and then try to produce answers, including the reasoning steps that are so good they look like they were made by a human expert. The critic's job is to look at both a real expert's answer and the generator's answer and decide which one is the real deal. This is called an adversarial setup, where both sides are constantly trying to outsmart each other. The generator gets a reward when it successfully fools the critic into thinking its answer is the expert's. Meanwhile, the critic is rewarded for correctly identifying the expert's work. This continuous competition forces the generator to not just get the final answer right, but to master the subtle art of how an expert reasons to get there. So, does it work? The researchers first tested it on a math puzzle called Countdown. The results were impressive. RARO performed significantly better than all other methods that didn't have a verifier and got nearly as good as methods that did. One of the most exciting findings was that the AI developed an ability to self-correct. It would try a solution, realize it was wrong, and then backtrack to try something else, just like a person would when solving a puzzle. They then scaled things up to the much harder deep math dataset. Here again, RARO came out on top, beating all other verifier-free approaches, and its performance improved as the AI models got larger. But the real test was on a completely open-ended task: poetry writing. This is a domain where a verifier is impossible, yet RARO substantially outperformed all baselines, showing it can learn to reason even in creative fields. We can see this in action here. For every task, whether it's math or poetry, the model trained with RARO first generates a reasoning step where it breaks down the problem and plans its approach before creating the final answer. So let's recap the key takeaways. The RARO method successfully trains AI to reason on complex tasks using only expert examples, bypassing the need for verifiers or constant human feedback. It achieves this through a novel adversarial game where a generator policy tries to fool a relativistic critic. This is a huge step forward because there is a vast amount of expert demonstration data available in the world, from websites like Stack Exchange to financial reports and literary works. The ability to tap into this data could enable a new wave of AI applications that can tackle complex, real-world problems where the path to the solution is just as important as the solution itself.